Hey there, fellow deep divers.
Yeah.
Ready for another journey back in time?
Absolutely.
Awesome. Well, today we're going to be diving into the Mesozoic era.
Sounds fun.
Yeah. To explore some fascinating new discoveries about prehistoric marine reptiles. So we're talking about those dolphin-like ichthyosaurs and the incredibly long-necked Tanistropheus.
Oh, yeah. I've been reading about those.
Yeah. They're so cool, right?
Absolutely.
We've got articles and research notes ready to go to really uncover how these creatures ruled the ancient seas.
You know what's really fascinating to me is how these findings, they really challenge old assumptions. Like, for instance, we're going to learn how a giant ichthyosaur might have had a more diverse palate than we initially thought.
Wow.
We'll even try to tackle the breathing puzzle of how Tanistropheus managed to survive with such a long neck.
Yeah, that's always gotten me. Okay, let's kick things off with schoenosaurus.
Okay.
A true behemoth of the late Triassic.
Mm-hmm.
Imagine a creature reaching lengths of 15 meters,
Mm-hmm.
almost 50 feet.
Wow.
That's longer than a school bus.
Yeah, that's huge.
And it was long thought that this schoenosaurus
Yeah.
was toothless. It's
Yeah,
kind of
okay.
gliding through the water, dieting solely on squid.
Oh, really? Well, hold on a sec. Recent research reveals that Schoenosaurus actually did have teeth.
Ah.
And these weren't just any teeth. They had cutting edges,
Oh, wow.
suggesting that they were, capable of tackling much larger prey than just squid.
So not just a gentle giant then, more like
Yeah.
a prehistoric orca.
Yeah, exactly. And get this, fossilized stomach contents also reveal the presence of hard-shelled mollusks.
Really?
Yeah, so it seems Schoenosaurs wasn't picky. They were likely opportunistic feeders, adapting their diet to whatever the prehistoric seas offered.
Wow, talk about adaptability. But here's where it gets even more intriguing. In Nevada's West Union Canyon, there's a dense Schoenosaurus graveyard
Mm-hmm.
where numerous individuals are buried together. Now, the catch is they didn't all die simultaneously.
Oh, really? So what happened? Well, for a while, the leading theory was that a colossal 30-meter squid, a true kraken of the Triassic, was dragging these massive ichthyosaurs to their doom.
Oh, my gosh.
A thrilling image, but likely not accurate.
I have to admit that was made for an epic prehistoric battle.
Yeah.
So what's the latest thinking on this Schoenosaurus graveyard?
Well, new research indicates that the site was likely a breeding ground. The key clue is the absence of juvenile Schoenosaurus fossils at the site.
Interesting.
This suggests they migrated much like whales do today, traveling between feeding grounds and specific breeding areas.
That's incredible. Are we talking about prehistoric migrations on a massive scale?
Precisely. And yet, their sort of migratory behavior would connect to various ecosystems, making Schoenosaurus a crucial player in the ancient marine food web.
Right.
It really shifts our perspective from seeing them as these solitary giants to understanding their impact on the wider prehistoric world.
All right, let's tackle another prehistoric enigma, the Tanistropheus. This reptile from the Triassic period was truly bizarre.
Yeah.
With a neck so long it almost defies logic, often mistaken for a plesiosaur, Tanistropheus actually had a stiffer neck with fewer but longer vertebrae.
I see. And that neck posed a real puzzle. How did it breathe efficiently with such a long trachea?
Yeah.
Think about it, all that extra space would make it incredibly difficult to get enough oxygen to the lungs.
Yeah, it's
Yeah.
like trying to breathe through a ridiculously long snorkel.
Yeah.
So how do they manage?
Well, nature, as always, is full of surprises. We see different solutions in other long-necked creatures.
Good.
Birds, for example, use air sacs to boost their respiratory volume.
Right.
Giraffes, on the other hand, have a narrow trachea to minimize that dead space.
Okay, so which strategy did Tanistropheus employ?
Well, recent research suggests it was more like the giraffe approach.
Interesting.
Tanistropheus likely had a narrow trachea and a slow, deliberate breathing rate to compensate for that extended airway.
Wow.
It's fascinating how evolution finds solutions, even for the most seemingly impossible anatomical challenges.
Speaking of solutions, imagine having a neck that's longer than your body. What kind of lifestyle did that allow Tanistropheus to live?
Well, their lung structure likely played a role too. They probably had multi-chambered lungs, capable of unidirectional airflow, constantly supplying fresh air.
Wow.
But even with this adaptation, their oxygen intake would still be limited.
So maybe not a long-distance swimmer then.
Exactly. The evidence points to Tanistropheus being an ambush predator, lurking in the shadows, and using that incredibly long neck to snatch prey from a distance. Talk about a prehistoric surprise attack.
Okay, picture this. A Tanistropheus lying in wait, perfectly still, and then bam, That long neck shoots out, snatching an unsuspecting fish or squid. It's like a prehistoric harpoon.
Exactly. And that, my friend, is a prime example of how form and function are intertwined in the incredible world of evolution.
Yeah.
But let's move on to another creature with a remarkable adaptation. Gingnathus, a pterosaur from the late Jurassic.
Pterosaurs. The flying reptiles. What are they mostly known for? Soaring through the skies, snatching fish with their sharp beaks.
True, but Gingnathus was a bit different. This pterosaur was a filter feeder, much like the more familiar pterodastro, proving that even among flying reptiles, there was a remarkable diversity.
Okay, color me intrigued. What made Gingnathus such a unique filter feeder?
Its jaw structure was unlike anything we've seen before.
Okay.
Imagine an upward curved upper jaw and a horizontal lower jaw. That couldn't fully close. This created a gap at the front, giving its broad, flat snout the appearance of, well,
A vacuum cleaner.
the vacuum cleaner. Now, that's an image I won't soon forget.
Right.
But how exactly did that work for filtering food? Wouldn't that gap in its mouth make it impossible to filter anything? Wouldn't the food just spill out?
That's an excellent question. It's believed that Gingnathus used its tongue to close the gap, forcing water through its teeth to filter out the food.
Wow.
Like a prehistoric water filtration system in action. So they sucked in water, closed the gap with their tongue, and filtered out food through their teeth. Now, that's what I call evolutionary ingenuity.
It's mind-boggling how nature comes up with these solutions. And it reinforces the idea that we're still just scratching the surface of understanding the vastness and complexity of prehistoric life.
Yeah, this is making me rethink everything I thought I knew
Yeah.
about these ancient creatures. They weren't just monstrous beasts. They were complex, adaptable animals with fascinating behaviors and lifestyles. But what about something a bit more down to earth? Literally, let's talk about trilobites.
Okay.
Those iconic fossils often found in rock formations. What's so special about Wallacerops?
Well, Wallacerops stand out because of a prominent trident-shaped structure on their head. This feature has puzzled scientists for years. Was it for defense? Sensory purposes? The debate raged on until a new theory emerged.
Don't leave me hanging. What's this new theory all about?
Researchers now believe that the trident wasn't about practicality, but about attraction. It was likely a sexually selected trait used by males to compete for dominance, similar to the horns of modern beetles.
Wait, are you saying these little trilobites were engaged in prehistoric mating battle?
Exactly, and the evidence is intriguing. A four-pronged Wallacerops fossil suggests a non-detrimental genetic mutation, weakening arguments for feeding or digging functions.
Okay.
Researchers even compared the trident to the horns of rhinoceros beetles, known for using them to flip rivals.
Oh, wow. So these weren't just passive creatures scuttling along the seafloor. They had complex social interactions and maybe even some epic showdowns for mates.
Exactly.
But is this just a theory or is there concrete evidence?
Well, while the evidence is compelling, more fossil finds are needed to confirm this theory. Specifically, we need to determine if female Wallacerops lacked the trident.
Okay.
But even as a theory, it opens a fascinating window into the complex behaviors of even the smallest prehistoric creatures.
Okay, I'm officially hooked on this prehistoric drama. What other secrets are we uncovering today?
Let's turn up the volume, shall we? It's time to explore the world of ankylosaurs and their surprisingly loud voices.
Ankylosaurs. Those heavily armored dinosaurs. With the clubbed tails, I always pictured them as silent giants,
No,
lumbering through the prehistoric landscape.
we'll prepare to be surprised. Exceptionally well-preserved ankylosaur fossils have revealed astonishing details about their vocalization capabilities.
Wow.
Yeah, this is a big deal because throat structures are rarely preserved, giving us a rare glimpse into dinosaur communication.
Hold on, are you saying these armored tanks could sing?
Maybe not singing in the traditional sense, but they definitely had a way with sounds,
Okay.
while lacking a syrinx, the vocal organ found in birds. Ankylosaurs possessed a large mobile larynx, capable of fine-tuning airflow, just like birds.
So a different kind of voice box, but still capable of producing complex sounds.
Precisely. And the similarities don't stop there. The ankylosaur larynx shares features with parrots and songbirds, suggesting they could produce a range of complex vocalizations, perhaps even loud calls.
Wow. I never imagined these armored behemoths being so chatty. But why would they need such complex vocalizations? Was it just about scaring off predators?
Well, their calls likely served various functions: mating displays, territorial disputes, parental calls, and even defense. Remember, they had tail clubs, good hearing.
Yeah.
and complex nasal passages, all signs pointing to a social species. That relied on communication.
Okay, so they were like chatty. Armored tanks. That's an image I'm definitely going to hold on to.
It is pretty amazing.
But you mentioned that ankylosaurs belong to a group known for complex vocalizations. Does that mean all dinosaurs were equally vocal?
That's a great question. It's tempting to generalize, but remember, each dinosaur species had its own unique adaptations.
Right.
For example, their close relatives, the nodosaurs, lacked many of these features, and likely had simpler vocalizations.
So it's all about context and looking at the bigger picture, right?
Well, precisely. Each discovery gives us a piece of the puzzle. But we need to avoid making sweeping assumptions. The world of dinosaurs was incredibly diverse, and their communication methods probably varied as well.
This is incredible. I feel like we're just starting to understand these amazing creatures. What other prehistoric mysteries are we going to uncover today?
Let's dive into the fascinating world of early ichthyosaur evolution with Shastasaurus.
Ooh, Shastasaurus. That name sounds like something straight out of a science fiction novel. What's the story behind this mysterious creature?
Well, for years, Shastasaurus was an enigma, kind of, known only from fragmentary fossils, making it tough to reconstruct its appearance and behavior. But, recent research has shed light on its evolutionary history, and let me tell you, it's more captivating than we initially imagined.
All right, you've piqued my curiosity. What's so captivating about this Shastasaurus?
Well, new research links Shastasaurus to the early Triassic Mixosauria, specifically the unusual Wemanius, and Phalarodon.
Mixosauria, Wemanius, Phalarodon. Those names are a mouthful. Could you break those down for us?
Of course. Mixosauria is a group of early ichthyosaurs,
Okay.
and Wemanius and Phalarodon are two of its members. They were initially thought to be toothless suction feeders, gracefully gliding through the water, sucking up small prey. But hold on to your hats, because this new research has unearthed a shocking twist.
Don't tell me they had teeth.
You got it.
Thank God.
And not just any teeth, like Shastasaurus. They possessed crushing teeth, revealing a durophagus diet.
Durophagus, reminding me of that word. It means they ate hard-shelled prey, right?
Exactly. They were shell crushers, feasting on creatures like ammonites and other hard-shelled invertebrates.
Okay, so we've got these three related reptiles.
Yeah.
Shastasaurus, Wemanius, and Phalarodon, all rocking those crushing teeth for a shell-crushing diet. What does this tell us about the bigger picture of ichthyosaur evolution?
Well, this discovery was a game changer. It led to the reclassification of these reptiles into the family Shastasauridae, placing them at the very base of Ichthyopterygia.
Well, slow down a sec. So these shell-crushing enthusiasts were some of the earliest ichthyosaurs to evolve.
Precisely. And it challenges previous assumptions about early ichthyosaur evolution.
Right.
We used to think these early ichthyosaurs kind of stepped to shallow waters,
Right.
but now they were already venturing into the open ocean and specializing in crushing shells much earlier than previously believed.
This is rewriting the textbooks, isn't it? It's amazing how one discovery can reshape our entire understanding of a group of animals. But how did these early ichthyosaurs eat if their bite wasn't that powerful to crack those shells?
Excellent question. Instead of relying on brute force, they likely used a grinding motion to crush their hard-shelled prey. Scientists even suggest they might have had turtle-like beaks for capturing those ammonites out in the open ocean.
So more like prehistoric nutcrackers than ferocious chompers.
Fascinating. But hold on, you said open waters. Weren't early marine reptiles thought to be confined to those shallow coastal areas? Well, that was the prevailing theory. But the wide distribution of Shastasaurid fossils across the northern hemisphere kind of throws a wrench in that idea.
Yep.
These fossils suggest they were already comfortable cruising the open ocean, making them true trailblazers of the prehistoric seas.
Talk about exceeding expectations. We've gone from toothless squid eaters to shell-crushing open ocean pioneers. This just goes to show that we should never underestimate the adaptability and diversity of ancient life. What other surprises are waiting to be unearthed in the fossil record?
Well, one thing that never ceases to amaze me is how these prehistoric creatures evolved to thrive in their environments. Take Tyrannosaurus rex, for example. Its massive teeth and bone-crushing bite force weren't just for show.
Well, I can only imagine those teeth were legendary. But how did those teeth specifically help T-Rex survive and rule its domain?
Well, remember, T-Rex was an apex predator at the top of the food chain.
Right.
Those teeth and that bite force were perfectly adapted
Yeah.
for taking down large prey, like Triceratops and other herbivorous dinosaurs.
So it was all about raw power and brute force, just chomp and go.
Not entirely. The shape of the teeth played a crucial role, too. T-Rex's teeth were thick and serrated, like steak knives, perfectly designed for crushing bone and tearing through flesh.
Ouch. I definitely wouldn't want to be on the receiving end of that bite. But what about the force itself? Just how powerful was a T-Rex bite?
Well, estimates vary, but some scientists believe T-Rex could generate a bite force of up to 12,800 pounds.
12,800 pounds. That's heavier than a pickup truck. No wonder it could pulverize bones. But how on earth did they figure that out? It's not like they can just hand a T-Rex a pressure sensor.
That's where the magic of biomechanics comes in. Scientists use sophisticated computer models and simulations to estimate bite force based on the size and shape of the skull, jaw muscles, and those fearsome teeth.
It's like a prehistoric CSI episode using technology to unlock the secrets of the past.
Yeah.
Amazing. But it wasn't just about the bite, was it? T-Rex must have had other tricks up its sleeve to become such a successful predator.
You bet. Its keen sense of smell, powerful legs for chasing down prey, and binocular vision for depth perception all contributed to its success.
Wow.
T-Rex was a true marvel of evolution, a perfectly adapted killing machine.
Speaking of adaptations, let's circle back to the long neck of Tanistropheus. It's mind-boggling how such a bizarre feature could actually be advantageous for survival.
It's a prime example of how evolution can produce some truly strange and wonderful adaptations. Remember how we discussed Tanistropheus's likely lifestyle as an ambush predator?
Yes, lurking in the shadows,
Yeah.
waiting for the perfect moment to strike.
Well, that lengthy neck would have provided a significant reach advantage, allowing it to snatch prey from a distance without even moving its body.
It's like a prehistoric fishing rod with a super extended reach.
Precisely, and it's likely that the neck also played a role in sensory perception, helping Tanistropheus detect prey and potential threats from afar.
So it wasn't just about looks, it was a multifunctional tool for survival. This is making me rethink everything I thought I knew about dinosaurs and prehistoric reptiles.
And that's the beauty of paleontology. It's a constantly evolving field, with new discoveries always challenging our assumptions and forcing us to reevaluate what we thought we knew.
Speaking of reevaluating assumptions, let's revisit Gingnathus, the pterosaur with the vacuum cleaner snout. Who could have imagined that filter feeding could be so complex and specialized?
It speaks volumes about the incredible diversity among pterosaurs. While some were soaring predators, with sharp beaks and talons, others like Gingnathus evolved to exploit different food sources with remarkable adaptations.
And he did it in style. I mean, a vacuum cleaner snout, that's both bizarre and ingenious. But I'm curious, how did this feeding strategy compare to other filter feeders, like the massive baleen whales we see today?
That's a fantastic comparison. While whales use those baleen plates to filter out krill and other small organisms, Gingnathus relied on its specialized teeth and tongue to do the filtering.
So different tools for the same job, but it all boils down to efficiency, right?
Yeah.
Getting the most out of those available food sources in their specific environments.
Absolutely. Evolution is all about finding solutions that work, no matter how strange or unexpected they might appear at first glance.
This deep dive has been an incredible journey of discovery. We've explored ancient oceans, uncovered bizarre adaptations, and even delved into those prehistoric mating rituals.
And we've only just scratched the surface. There are countless mysteries waiting to be uncovered in that vast fossil record.
Speaking of mysteries, let's revisit the trident-shaped structure on Wallace's head. We touched on the sexual selection theory earlier, but are there other possibilities that scientists have considered?
Well, some have proposed that the trident might have been used for digging in the sediment, searching for food, or perhaps as a sensory organ to detect vibrations in the water.
Okay.
But the evidence supporting those theories isn't as strong as the evidence for sexual selection.
So it remains a bit of an enigma. But that idea of these Trilobites engaged in battles for mates is just too good to resist. It adds a whole new layer of drama to the prehistoric world.
It's a powerful reminder that even ancient creatures had complex behaviors and social interactions. They weren't just mindless automatons. They were living, breathing animals with their own unique stories to tell.
And each new fossil discovery helps us piece together those stories, revealing a world that is both familiar and utterly alien. It's truly fascinating.
Absolutely. And the more we learn about the past, the more we appreciate the incredible diversity and resilience of life on Earth.
Okay, let's shift gears one last time and delve back into the vocal world of Ankylosaurs. Who knew these armored giants could be so chatty?
It's a discovery that has truly revolutionized our understanding of dinosaur communication. Remember how we talked about their complex larynx
Yeah.
and its similarities to modern birds.
Yes, it's amazing to think that these seemingly lumbering creatures could produce such a wide range of sounds. But how do we know what those sounds actually sounded like? Could we ever recreate those prehistoric calls?
Well, sadly, we can't hear the actual sounds they made. However, scientists are using cutting-edge computer models and comparisons with modern animals to reconstruct those possible vocalizations.
So it's like composing a prehistoric soundtrack. What do they think ankylosaurs sounded like? Were they roaring like lions? Or chirping like birds?
Well, based on the structure of their larynx, they likely produced deep, resonant calls, perhaps similar to the bellows of crocodilians or the low rumbles of elephants.
Wow, I can practically hear those sounds, echoing through the ancient forests. But what about their close relatives, the nodosaurs? Didn't she say they were less vocally gifted?
That's right. Nodosaurs lacked the complex larynx of ankylosaurs and probably had simpler vocalizations, perhaps grunts or hisses.
So even within the same family of dinosaurs, there was a wide range of vocal abilities. It's another reminder of just how diverse the world of dinosaurs truly was.
Absolutely. And each new discovery reminds us that we still have so much to learn about these fascinating creatures and their place in Earth's history.
This deep dive has been an incredible journey of discovery. We've explored ancient oceans, uncovered bizarre adaptations, and even delves into those prehistoric mating rituals. But what truly stands out to me is how interconnected everything is.
I couldn't agree more. From the tiniest trilobite to the mightiest dinosaur, every creature played a role in the complex web of life, and each new discovery helps us weave together that web, revealing a world that is both familiar and utterly alien.
It makes me wonder about all the mysteries that are still out there, just waiting to be unearthed. What other secrets are hidden in the vast fossil record? What new discoveries will rewrite our understanding of the past?
That's the beauty of paleontology. It's a constantly evolving field, full of surprises and challenges. And with each new fossil we uncover, we get a little closer to understanding the incredible story of life on Earth.
This deep dive has been an amazing journey through time, but unfortunately we've reached the end of our exploration for today.
It's incredible to think that by studying these fossils, these snapshots of the past, we can learn so much about the challenges and triumphs of life millions of years ago.
Yeah. And speaking of adaptations, we saw how even the bizarre, almost outlandish features, like the super long neck of Tanistropheus, were key to survival. Who would have thought that a neck could be both a hunting tool and a sensory organ?
Yeah, it goes to show that evolution doesn't always follow a straight path. Sometimes the most unexpected solutions are the most effective.
Absolutely. And who could forget Gingnathus, the pterosaur with the vacuum cleaner snout? Talk about thinking outside the evolutionary box. It just blows my mind how nature comes up with these incredible solutions for finding food and surviving in a competitive world.
It makes you wonder, what other bizarre adaptations are still waiting to be discovered, hidden within those ancient rocks? Just waiting for a curious paleontologist to unearth them.
Speaking of hidden wonders, we can't overlook the intriguing possibility of those trilobite mating battles. It paints such a vivid picture of these seemingly simple creatures engaging in complex social behaviors. It's a reminder that even in the prehistoric world, there was competition, strategy, and maybe even a little bit of drama.
And then there's the revelation about ankylosaurs. Who knew these armored tanks were such chatterboxes?
Yeah.
It's amazing to think that they might have had a range of vocalizations for communication, perhaps even regional dialects.
Regional dialects. Now that's a thought-provoking image. I could just imagine groups of ankylosaurs from different regions, each with their own distinct calls and accents.
It really underscores the richness and complexity of the dinosaur world, a world that we're only just beginning to comprehend.
So what does this all mean for us today? Why should we, in the 21st century, care about these long-gone creatures and their prehistoric lives?
Well, for one thing, studying these extinct animals gives us a deeper appreciation for the incredible diversity and resilience of life on Earth. It's a reminder that our planet has a long and fascinating history, a story that is constantly unfolding.
It's like reading an epic novel,
Yeah.
with each new fossil discovery, adding another chapter to the story. And sometimes those new chapters completely rewrite the plot.
Exactly. And by understanding the past, we can gain valuable insights into the present and even the future. For example, studying the adaptations of prehistoric creatures can inspire new technologies and solutions to modern-day challenges.
Right.
Think about how the streamlined shape of ichthyosaurs has influenced the design of submarines,
Yeah.
or how the lightweight but strong structure of dinosaur bones could inspire new materials for construction.
It's a great point. It's like having a blueprint
Oh.
from millions of years of evolution
Okay.
ready to be tapped into for inspiration and innovation.
Exactly.
But beyond the practical applications,
Yeah.
studying paleontology also cultivates a sense of wonder and curiosity about the natural world.
It reminds us that there's always more to discover, always new mysteries to unravel. And that's what makes it so exciting. Every new fossil find has the potential to rewrite the textbooks and revolutionize our understanding of the past.
And who knows, maybe one of our listeners will be the next paleontologist to unearth a groundbreaking fossil, to make a discovery. That changes everything we thought we knew about prehistoric life.
That's the beauty of science. It's a never-ending journey of exploration and discovery. And we invite you to join us on this incredible adventure as we continue to delve deeper into the mysteries of the past.
Well, folks, it seems we've reached the end of our deep dive for today. We traveled millions of years back in time, encountered incredible creatures, and uncovered some truly mind-blowing adaptations.
It's been an absolute pleasure sharing these fascinating discoveries with you.
And remember, the world of paleontology is constantly evolving, with new discoveries happening all the time. So stay curious, keep exploring. And who knows, maybe you'll be the one to make the next groundbreaking discovery. That changes the way we view the prehistoric world.
Until next time, keep those imaginations fired up and those prehistoric passions burning bright.
And keep diving deep into the amazing world of science. We'll see you on our next adventure.